Hi everyone, this is Mrs. GA, and today we're going to talk about reasoning and proof. Alright, so we're going to start with a little bit of vocabulary. So first we have the word conjecture. So conjecture is just a statement that is believed to be true. So that's kind of the starting point for all of our reasoning and proof. We make some sort of conjecture. And then we're either going to use inductive reasoning or deductive reasoning to see if this conjecture is true or not. So inductive reasoning is the process of reasoning that something is true by looking at specific cases, while deductive reasoning is the process of using logic to prove whether all cases are true. So I'll show you a comparison of those two on the next slide. A theorem is a statement that a statement you can prove is true using logical steps. So we're going to learn a new theorem today. A counterexample is just an example that proves that a conjecture is not true. A conditional statement is really just an if-then statement. It does need to have the words if and then, and we call the if part of the statement, the P, we call that the hypothesis. This is an important thing to know. And the Q part of the statement, the then part, we call the conclusion. And last, in this new theorem we're going to use the word supplementary. So supplementary by definition means that it adds up to 180 degrees, which remember is just a straight line or half of a circle. So here I want to show you the difference between inductive and deductive reasoning. So here's also an example of a conjecture. So the sum of three consecutive counting numbers is divisible by 3. So first we need to interpret what this means. Hopefully we know that sum is telling you to use addition. 3 consecutive, the word consecutive means like in a row, or it means the next one. Counting numbers are numbers that you would use to count something, so it means not negative numbers and no fractions or decimals, and we start at 1. And then we say, is divisible by 3? Well, divisible means that you can divide by 3. There we go. So if I were to do inductive reasoning to try to see whether this conjecture is true or false, I would come up with a specific case. So I'd say, okay, let's actually add up 3 consecutive counting numbers and see if it's true. So let's say we do 8 plus 9 plus 10. So 8 plus 9 plus 10 is 27. And then we can say 27 is divisible by 3. So here we just looked at a specific case. We said, okay, for these 3 numbers, I added them up and it is divisible by 27. However, deductive reasoning is a little bit more, it's more logic-based and it covers all possible answers. So we're going to do this with some variables actually. So let's say that n, I'm going to call that our first number. So I say n plus, well, the next counting number is just one number higher, so n plus 1. And then the next one would be n plus 2. So this is a more general way to describe 3 consecutive counting numbers. And we can combine like terms. N plus n plus n is 3n. 1 plus 2 is 3. And you'll notice that they actually have a common factor of 3. So I can factor it out. And I can see, because I have a 3 right here, that this is divisible by 3. So this would be deductive reasoning. So again, it's logic-based and it covers all possible scenarios to prove that our conjecture is correct. So specific case versus logic-based general case. Okay, now we're going to practice writing conditional statements. So remember, conditional statements are those if-then statements. So we're going to see if we can turn this into an if-then statement. So all of Mrs. GA students go to Saratoga High School. So from that, I can write this as, if you are Mrs. GA's student, then you go to Saratoga High School. So notice this wouldn't make sense if you flipped the if and then. You can't say if you go to Saratoga High School, then you are Mrs. G.A. student, because that wouldn't be consistent with what the information is here. So if you are Mrs. G.A. student, then you go to Saratoga High School. So that's the conditional form of this statement. Let's look at this next one. You will do better on the quiz if you complete all your homework. So this one we can write as if you complete all homework, then you do better on the quiz. So you'll notice that the if part of our statement doesn't always come first. You have to read the statement to see which part would be your hypothesis and which part would be your conclusion. Now we're going to use deductive reasoning to write a conclusion based on some true statements. So let's look at this first one. Any number ending in 0 or 5 is divisible by 5. 12,475 ends in 5. So I'm wondering, what can we conclude about the number 12,475? Well, it says any number ending in 0 or 5. Well, this ends in 5, so this must be true. So we can write 12,475 is divisible by 5. So this is our logical statement that we can make using deductive reasoning. Let's look at this next one. None of Mrs. G.A. students are seniors. Ruby is Mrs. G.A. student. So again, Mrs. G.A. student, Ruby is Mrs. G.A. student. None are seniors, so we can logically deduce that Ruby is not a senior. So if this part is true about Ruby, then this part must also be true about Ruby. Okay, and now we're going to look at a conditional statement and identify the hypothesis and conclusion. So this first one says, if, so here's our if, a student does their homework, then they will do better on tests. So that means that our hypothesis is a student does their homework. The conclusion is they do better on tests. Okay, let's look at this next one. Adriana will go to the dance if she finishes all of her homework. So the if statement is right here. So again, this time it's at the end of our sentence. And the then part would be the first part. So our hypothesis is Adriana finishes her homework. The conclusion would be Adriana goes to the dance. And there you have it. So now we're going to talk about how we can use properties, postulates, and theorems to help us prove that something is true. So here's a new one that I want to make sure you guys know. This is the linear pair theorem. So this theorem states that if two angles form a linear pair, which means essentially they make a straight line together, then they are supplementary, which again means that their sum is 180 degrees. So if you look at this figure, we can make this statement, the measure of angle 3 plus the measure of angle 4 equals 180 degrees using the linear pair theorem. So this linear pair theorem would be a justification for this statement. Here's a few other postulates about points, lines, and planes that you could use to prove something is true. So through any 2 points, there's exactly one line. Through any 3 non-collinear points, there's exactly one plane containing them. So here's a picture for that. If 2 points lie in a plane, then the line containing those points also lies in the plane. If two lines intersect, which means cross, they intersect at exactly 1 point. And if two planes intersect, then they intersect in exactly one line. Here's another set of properties or postulates that you should already know. In the previous lessons, we've talked about segment addition postulate, which remember is just small part plus small part equals big part, and the angle addition postulate. Like here, angle 1 plus angle 2 would be the larger angle, angle LMQ. And here are a bunch of properties of equality that you learn from Algebra 1, so we can actually use them in reasoning and proof. So we have the addition, subtraction, multiplication, division property of equality. So that's just essentially when you do the same thing on both sides. Reflexive property of equality is that something equals itself. Symmetric property of equality is essentially you can flip what's on either side of your equal sign and it is still equal. Here, transitive property of equality. If A equals B and B equals C, then A equals C. And substitution property of equality. You guys substitute all the time. So it does have a name that you could use if you were doing a proof. All right, we're going to do a couple proofs. We're going to solve for this, but we're going to provide reasons as we go along. So here you can see that we have two adjacent angles and we have some given information. So the first thing I'm going to do is I'm going to create this equation, and this is a really important step that I want everyone to take. Angle RSP plus angle PST equals angle RST. And for this, my reason would be the angle addition postulate. Okay, so we're doing a proof. You have to provide justification for every step you take. So now I'm going to look at my figure and I'm going to substitute what I see. So I see RSP is x plus 25. PST I can see is labeled 5x plus 10. And I can see in the given, angle RST is 15x minus 10. So this we could say is the substitution property of equality. I abbreviate that with POE. And now we're just going to combine like terms. So we have 6x plus 35 equals 15x minus 10. So this is just combined like terms. So I'll write that as our reason. Okay, so now you know that our next step, if we were solving this equation, would be to subtract 6x from each side. So we get 35 equals 9x minus 10, and it has a reason. This would be the subtraction property of equality. And then I would add 10 on both sides, which would be the addition property of equality. And then we would divide by 9 on each side, which would be the division property of equality. And last, if you really want, we could say x equals 5, which would be the symmetric property of equality. So these are all things that you have been doing in Algebra 1 and in geometry, but now we're just going to provide reasoning for them. However, we're not done with this problem because they ask us to find the measure of angle RST. So then I'm going to go over here and I'm going to say, okay, angle RST equals 15x minus 10, and this has a reason as well. In this case, our reason is given. We can say that as a reason. Then we'll say angle RST equals 15 times 5 minus 10. So this would be the substitution property of equality. And then here, 15 times 5 is 75 minus 10 is 65. So we can say the measure of angle RST is 65 degrees. And now we are done. So you can see that, again, this is stuff that you've been doing. Now we're just giving it a reason because we're doing a proof. All right, let's try another one together. So here I see a figure and we have a couple pieces of given information. And overall, they would like us to find the length of line segment ST. So again, I'm always going to start with this type of equation. I'm going to say RS plus ST equals RT. And my reason for that is the segment addition postulate. And now I'm going to substitute what I know. So x plus 2 plus 3x minus 8 equals 5x minus 12. And that would be the substitution property of equality. And now I can combine like terms. So x plus 3x is 4x. 2 minus 8 is negative 6. Equals 5x minus 12. So we can say combine like terms. Here I will subtract 4x from each side. Negative 6 equals 1x minus 12. That would be the subtraction property of equality. And then we'll add 12 on both sides. And we get 6 equals x. That would be the addition property of equality. And then we can even rewrite it as x equals 6, which would be the symmetric property of equality. Now again, we did not just want to find x, we want to find actually the length of ST. So then over here, we're going to finish our problem by saying ST equals 3x minus 8. Our reason for that is given. And then we can substitute. So we have 3 times x, which is 6, minus 8. 3 times 6 is 18, minus 8 is 10. So it's 10 units. And again, our reason here would be the substitution property of equality. And there you go. Okay, we're going to try one more together. So this one says, if angle LMK and angle KMP are a linear pair, and then we have more given information. We know LMK is 2x plus 7, and angle KMP is 3x plus 3. They ask us to solve for x and then find the measures of the two angles. So I am going to draw a picture before I do anything else just to help us visualize. So as soon as I see the word linear pair, I'm going to draw a straight line. And then I'm going to look at the angles. I notice that the one point they have in common is M, so I know that that must be the vertex. And then I have something like this. So we can call this LMK and then KMP. So now I can label what I know. Angle LMK is 2x plus 7. KMP is 3x plus 3. And I know that linear pairs are supplementary, so they will add up to 180 degrees. So before I do anything else, I'm going to write this statement. Angle LMK plus angle KMP equals 180 degrees. And my reason for this is the linear pair theorem. So that's my reason. Now I can substitute. So 2x plus 7 plus 3x plus 3. Notice whenever we substitute, we use parentheses. Equals 180. That's the substitution property of equality. Now I can combine like terms. 2x plus 3x is 5x. 7 plus 3 is 10. And I have 180. That's just combining like terms. Okay, here, let's subtract 10 on each side. 5x equals 170. And again, subtraction, property of equality. And last, we'll divide each side by 5. And we get x equals 34, which would be the division property of equality. And here's part of my answer. It did ask us to solve for x, but now we need to find the measures of angles LMK and KMP. So I'll do that on the side. So we'll start by saying angle LMK is 2x plus 7, and that is given. Angle LMK is 2 times 34 plus 7. That would be the substitution property of equality. And then we're just going to simplify from there. So if we have 2 times 34 plus 7, we get angle LMK equals 75 degrees. That's part of my answer. Now we're going to do the same again for angle KMP. So angle KMP is 3x plus 3. Again, that is a given. And then we're going to use the substitution property of equality and substitute it right here. If we do 3 times 34 and then we add 3, we get 105. So the measure of angle KMP is 105 degrees. So now we can double check that we've answered our question fully, and we have. So we are done. So again, a step that I'm definitely going to be looking for is that you're setting up the initial equation using either the linear pair theorem, the segment addition postulate, or the angle addition postulate. And the rest we're just substituting and solving. All right, that is all for today. Thank you so much for watching.